Good morning, guys. Today we're going to look at analyzing categorical data. In the last section, we talked about being able to take variables and kind of classify them as quantitative or categorical. So today our focus is going to be on the categorical data. So let's start off with a good categorical variable here. We have results of the Pew Internet Parenting Privacy Study from 2012. They talked to 185 12 to 17-year-old respondents and asked them what type of information had you posted about yourself online. And these are the responses that they had given. So we have photos of yourself, school name, where you live, email address, cell phone number, a bunch of stuff you probably shouldn't be putting online. Then we have how many people responded and their percentages. So let's kind of go over a little vocab from the last chapter. Remember, I told you it's our last section, it's going to be coming in a lot. In this study, what would we consider the individuals? Remember, individuals are the people that we're learning about, or objects we're learning about. Good. The individuals are going to be these 185 12 to 17-year-old respondents. Those are the individuals. Now, individuals are who we learn about. The variables, what we learn about them. So what is the variable in this case? So specifically, what we're learning about them is the type of info posted. These would not be variables. Okay, so the type of info posted would be our variable, right? This is the general idea of what we're learning. These would be considered values, like we talked about in the last section. So the values are the specific outcomes that the variable can take on. So these, photo, school, city, email, cell phone, these are called values. So we know who we're learning about, we know how many people there were, we know what the variable is and what the values the variable takes on. All right, so let's kind of talk about the count. So how often each of those values was responded, how many people gave those answers. So we've talked about count, how often something occurs before, and that word was frequency. So that's the frequency, and then we've converted those into percentages. So 91% of the students said how many people that they would post photo of themselves. 71% of the teenagers said they would tell people online where they live. So those are still talking about how many people responded, but it's relative to the whole. So we would actually refer to that as relative frequency. So relative frequency is just a fancy way of saying percentage. So it's just converting your data, your counts, your frequencies into percentages, parts of the whole. All right, so let's talk about how we could take something like this and maybe put it in a graph. So there are two types of graphs we really focus on when we're dealing with categorical data. We deal with pie charts and bar charts, and you've worked with both of these in the past. So if we were going to do a pie chart, we would just take each one of these values and they would represent a slice, right? So each value represents a slice of the pie. So let's say that we do a photo of themselves. So that's a big slice, that's 91%. So you'd have to have something that probably looks like that. All this stuff would have to be photo of themselves, okay? Because that's 91%. Leaves you just 10% right in there. All right, so now if we were to go to do school name, well, school name is 71%. Well, we have a problem here. I don't have 71% left to work with. Remember, each value represents a slice of the pie. Well, you know how pie is. Once you take a piece out, you can't really, if you're not sharing your pie slice, you can't really give that out. So once you use 91% of the slice up, you're really only left with 9%. And we don't have 9%. We've got way more than 9%. So a pie chart in this case wouldn't really work. So some rules to help us decide if a pie chart's reasonable. We need all relative frequencies to total 100%, which these are way over 100% when we add all of them up. Okay. We also need all values or all counts to come from the same whole. The same big group. Well, these all do come from the same group, so that's not really an issue. So that might be something if we had information about one country and things happening in one country, and then the same thing happening in another country, and the same thing happening in another country. That's are counts from a lot of different groups. A pie chart wouldn't really work in that case either. All right, so what's causing the problem in this one? The problem in this one, we are dealing with just one big group, but people can repeat answers. So the reason our pie slices are overlapping in this case with some 71, some 91, is because some of the teenagers could have actually given multiple response. So the last thing to say, yeah, we got a pie chart, is we need to make sure that each individual only takes on one value. All right, so in other words, no repeat answers. You can't have a select all that apply type situation and be able to use a pie chart. All right, so that's what a pie chart is. All right, so now let's look at a bar chart. Now, bar chart we really like because a bar chart doesn't look at trying to put everything in one circle in one group. It really just looks at every value as an individual answer. So it gives one bar per answer. So you could have one bar per country or one bar per type of information. So a bar chart, we like it because it always works. Bar chart, best one right there for what we do, because you're always going to get a good answer. You get a good picture from a pie chart, but it's not always applicable. So what is a bar chart? All right, it has two axes. Two axes. It has a vertical axis and a horizontal axis. Now, most of the time people will organize it like this, where you do the numbers on the vertical part and your other information on the horizontal part. It really doesn't matter. You can have your bars going sideways or vertical. The key is that one axis, so axis 1 has the values, and then axis 2 has the frequencies, or relative frequencies. Relative frequencies, converting them to percentages, that's really useful if you're comparing two groups that maybe have different size. Another thing that we have to make sure is we don't want bars to touch if they're not related somehow. So usually with a bar graph, there's gaps between the bars. So bars of different values, not different heights, different values, meaning different variable responses, should not touch. All right, so let's go through and let's try to make a bar graph. Use the green marker. All right, so we said we get one axis that has the values, one axis that has their frequencies. Most of the time we'll put the values across the bottom. So let's label this. All right, so one axis has the values, which we have there, and then the other axis has the frequencies. All right, so that's how many individuals. Now, if I'm looking at this, because the information I'm given, which one of these do you think is going to be easier to put on a number line? Numbers that go from 37 to 168, or percentages that go from 20 to 91? Yeah, I'm probably going to go with the percentage one, especially when I have a really big group. Maybe if I have a small sample, 10, 20, maybe less than 30, things like that, the counts could be easier to reflect things. But if I've got a large sample, the percentages kind of have a little more meaning to me. So I'm going to do these percentages. So I'm just going to label this axis percent of respondents. So we're going to go from 0%, got to get all the way up to 91, so we'll just go to 100. 20%, 40%, 60%, 80%, 100%. Okay. Now let's go in and make our bars. So all we have to really make sure is the bars don't touch each other. All right, so let's look, photo of himself, 91%. Now the way I like to do these is I like to find my percentage first. So right about there, and draw where the top of my bar is going to be. Just gives me a little more uniform type of bar when I do it that way. Then we had 71% for school name. Okay, so I'm going to go top of the bar. City was also 71%. Notice how these are different values, so they're not touching each other. Email was 53%. And photos 20%, or sorry, phone number was 20%. So where the numbers are really nice to look at, a picture kind of sums all that stuff up even better. Okay, so you had a very few kids over here that were putting something I really shouldn't, which is their phone number. About almost 2/3 of them were telling people where they lived, and then others were putting, a lot of them were putting some types of photos online. Hopefully they were safe photos. So this is how we can graphically organize categorical data. This is going to be our big focus this year. Occasionally we'll work with pie charts, but it's hit or miss on when we can use them. So these give us a little bit of picture. And we're going to look at something a little bit later where bar graphs are actually a really, really good visual when you're looking at two variables instead of just one variable like we did here. All right, next what I want to do is I want to look at what type of graphs can we use. We talked about bar graphs are really, really good. Well, we can kind of get a little more creative and get things that are like bar graphs, like a pictograph, things you've worked with. But let's look at this graph right here and talk about what pictographs and kind of how to be responsible with them. So if we look at this graph right here, it's nighttime star visibility in New York City, and it goes from 1968 to 2018. So it's given us, we can see percentages over here, gives us an idea of how much visibility you could see in the nighttime sky in New York City. So if we look at this, looks like over that, 50-year span, so we're kind of increments of 25 years. Over that 50-year span, it looks like we used to be able to see a whole lot in New York City. Now we see just a tiny bit right here. And so looks like it's gotten a whole lot worse. But if we inspect a little more carefully over here, it really just went from 3% visibility to 1% visibility. Well, we get that information from the graph, but the graph's kind of misleading. Using these pictures was misleading. All right, so we always, when we work with things with pictures, I always want to just kind of beware of pictographs. Graphs that use pictures instead of bars. If you're going to use those to clearly communicate, because if you notice like we did right here, notice how my bars were kind of the same width every time. I didn't want one to look like it had more geometry to it, more area to it. I just want to compare heights. I don't want to compare area. And you can see this one, we weren't just getting shorter, we were also getting narrower. So if you're going to use pictographs, don't use scaled images. Scaled images means that as they get taller, which is what we usually want, they also get wider. So again, they give more weight to it. So this one would have been a better looking picture had we done something like just taking a star all the same size and just stack them up instead of stretching it out. So that one would have had 2. Now we can see the same information but we're getting a lot better picture like that. So it more clearly communicates, okay, it decreased by quite a bit, but it doesn't look like it was as extreme a thing as it did in the first one. All right, now the second, this is just a regular bar graph. We're not touching, everything's good. So if we look at this, these are 2016 spring math scores. So we had IM1, IM2, IM3. So it's kind of what percentage of the group mastered, or mastered the exam. So if we look at it, initial glance, looks like IM3 and IM1 were terrible. IM2 just blew them out of the water, right? It's just so much better. I mean, especially IM3 looks like IM2 looked like they may have done 5 times better. Here they probably did about 2 or 3 times better. But something you have to be careful, look over here on the side. If we inspect, these guys were at 20% in IM1. 1 in 5 mastered it. Here we were at 24% in IM3, about 1 in 4 mastered it. And here you're at 19% in IM3, close to 1 in 5 again. So if you'll notice, there really was only about a 4 or 5% difference in mastery. 1 or 2 students here or there. Sorry, just a few students here or there. So the problem with this one is our scale. Okay, we didn't start at 0 like we should have. So you always want to inspect, I was going to say analyze, inspect the frequency axis to make sure that it's scaled uniformly, and if possible, try to start at 0. I know sometimes it's not if you're doing like thousands and thousands, but we could at least have done a little jagged break in the graph to give them some kind of indicator that, okay, this is just the top end of the graph, because there was a lot of stuff that was the same underneath. So just make sure we're inspecting the frequency axis, and we want to try to start at 0 so we can get a good picture. Again, the numbers, while the graph's nice if we can get things uniform, the numbers really tell a better story. All right, so now we're going to talk about two-way tables and marginal distributions, conditional distributions, all that type of stuff. So as I said before, a bar graph's really, really useful at kind of getting an idea of how groups compare to each other. Well, sometimes we don't want to just compare values within one variable. We want to compare values within one variable split between 2 groups, that type of thing. So that's what a two-way table does. It starts to organize things. Okay, so a two-way table allows us to compare 2 variables. Okay. Compares 2 variables for us. So for example, we have 100 students that we surveyed, and we just asked them 2 questions. What's your favorite P food, your favorite food that starts with the letter P, and what's your gender? So as we went through there, we got all these different responses. We got the guys here, and they said 25 like pizza, 20 like pancakes, 15 like pasta. Females, 10 like pancakes, 25 like 10 like pizza, 25 pancakes, and 5 like pasta. So there's our 100 students. So there's 2 types of pieces of information we can get from this. We can get what's called a marginal distribution, and we can get what's called a conditional distribution. They sound really, really scary, but they're pretty straightforward. So a marginal distribution says the distribution of only one variable within a two-way table. So that really means let's just look at one of the variables and see how it divides up. So if we look at gender, gender totals in this case were 25, 20, 15. So that's 60 guys, 10, 25, 5, 40 females. So this is our marginal distribution of gender. Right? So we know the distribution, which means the values, male and female, and how many there were, 60 and 40, for just one of the variables. So that's all we got right there. So marginal distribution of gender just tells me how many of each gender. All right, so I want you guys to take a second, tell me if you can figure out the marginal distribution of favorite pea food. Okay, So marginal distribution of favorite pea food is really just our subtotals for our pea foods. So pea foods, pizza, we had 35 students like pizza, we had 45 like pancakes, and we had 20 like pasta. So this is our marginal distribution of favorite pea food. What were the values? Pizza, pancakes, pasta. How many people responded each? 35, 45, 20 respectively. So that's what marginal distribution. We call it that because see how it's in the margins of the table? That's where they get the name from that. So I just like to think of marginal distribution as subtotals. What were my subtotals for my genders? What were my subtotals for my pizza? Okay, so it's the stuff on the outside of the graph. All right, so that's marginal distribution. Well, that's no different than what we had before, just looking at one variable. The more interesting thing is when we compare the two variables. And that's what conditional distribution does. It compares two categorical variables to each other. So I don't care just what was going on with gender, just what was going on with favorite pea food. I want to know, how did the gender relate to the favorite pea food? How many of the males wanted pizza? How many of the females wanted pasta, and so on. So the way it works is we would say something, not distribution of gender or distribution of favorite pea food. We would say distribution of the response variable for the explanatory variable. So one variable defined by the other variable. So what do we mean by response variable and explanatory variable? I kind of like, and this is not how we think of it always, but kind of just getting comfortable with it. I like to think of it as cause and effect. Explanatory, we can say, is kind of the cause variable. We're saying this causes, or maybe this influences the other one to happen, and then the response would be the effect. So which variable do we think is influencing or likely to possibly change? Okay. Now we're going to talk later, when does it cause an effect? That comes back to how we gathered our information and how we conducted our study. But this is kind of just my initial thought when I think explanatory response. Which one is more likely to be able to influence or help us predict? Okay, so this is kind of our predictor variable. So if we're looking at these two variables, we have gender, we have favorite pea food. Which one is more likely to influence the other one? Do we think it's likely that the favorite pea food could influence what somebody's gender is, or what they change what their gender is? Probably not. But do we think it's likely that your gender could influence what your favorite pea food is? Okay, maybe, maybe not, but of the two options, that's probably the more likely option. So it's probably more likely that your gender is going to influence your pea food in this comparison here. So in that case, the gender would be the explanatory variable, and the favorite pea food would be the response. So what we're going to look at is the distribution of favorite pea food for gender. So we want to look at our favorite pea food responses and break them down by genders. So this right here is good because it tells us how do we organize our graph. So I'm going to organize my graph by favorite pea food, because that's what we want. When I wanted distribution of gender, we needed to know the male and female gender and how many people. Well, I need to know the favorite pea food. So those are the values that we're actually going to put on the graph is favorite pea food. So, all right, now a lot of people make an error here, and they'll want to then put gender over here on this axis. That's not the way it works. So whatever you're doing distribution of your response variable, that's going to be, your response variable is going to end up being the horizontal axis, the way I organize it. And that means the explanatory variable is going to be the actual bars. Okay, not the height of the bars, but we're going to put those explanatory, those gender bars side by side. So what we're building right now is called a side-by-side bar graph. So I can look at each of these groups broken down and compare them side by side. All right. So to be able to put them side by side, I really don't want to do my male-female pizza side by side 25 to 10, because notice we have way more males than we did females, so you don't get that good comparison. So if you think back to what we talked about earlier, earlier we had said that if I have different group sizes, instead of working with frequencies, it's probably better to work with relative frequencies. So that's what we're going to focus on this. We're going to turn these into relative frequencies. Now, not relative out of the whole, but relative out of their proportion. So we're going to use this explanatory variable. We're going to use that to get the percents. So we said gender was explanatory, so I'm going to say 25 out of 60 males. So what percent of males prefer pizza? What percent of females prefer males prefer pancakes, prefer pasta? Same thing with the females. What percent of females? So out of the females. Out of the females there and out of the females there. All right, so we're going to look at these as percentages now so that we can actually compare, because we have those two different sized groups. So if we calculate those as percentages, 25 out of 60 is about 42%. 20 out of 60, that's a third, so that's 33%. 15 out of 60, that's a fourth, so that's about 25%. So that's what we're going to do. We're going to go to the males for pizza. So for, well, let's go ahead and finish these other percentages so just so we can see what they look like. So for the females, 10 out of 40, that's a fourth, so that's 25%. 25 out of 40, that's about 63%, we're just dividing it out. And then 5 out of 40, that's 1/8, so that's about 12.5, so about 13%. All right, so as you can see, our largest percentage is 63, so that'll help us set the scale over here. So just go by tens, 0, 10, 20, 30, 40, 50, 60, 70. Sometimes I won't even write all those. I may just write every other one just so you can set scale. So we'll just say percent of students. I'm going to put by gender. Percent of students by gender, because this isn't our percentage out of all students, it's out of those gender subgroups. All right, now we're ready to go. So let's see, I've got pizza. So if I look at my two groups, my pizza males were 42%. So pizza males, 42%, right about there. Just write male in there. Or we can put an M for male if you want. All right, then we look at our pizza females. They were 25%. It's a different color for that. Pizza females, 25%. Same with pancakes. Actually, you guys take a second. I want you guys to kind of follow in this. I want y'all to finish filling in this table real quick, or this side-by-side bar graph. So do male and female pancakes, and then male and female pasta side by side. All right, so let's go through and see what you guys came up with, see if it matches mine. Hopefully your graph came out looking like this. So important things to talk about with bar graphs. Remember, if the value is different, then the bars need to not touch. So my male and female bars can touch here because they're both talking about male and female pizza, or male and female pancakes, male and female pasta. But I do have a space between each of those groups right there. Now, I like this one right here. I think it's a really good example of why we need to convert these two percentages to relative frequencies. Because if we look between the pancakes, it's 20 versus 25. So it looks like the females have just a slight edge in pancakes. So 5 people, really not a big deal. But if we look at it as percentages, we can see that those females actually almost twice the rate of guys prefer pancakes. So I think it's a really good explanation how you can't really go with frequencies, go with counts, if your sample sizes are different. You really want to convert to those relative frequencies, to those percentages. So this is what a side-by-side bar graph looks like. Now there are other ways we can organize these. You could do a segmented bar graph, and we'll look at some of those. This is the one I prefer for us to work with because I think this gives us the clearest picture and the clearest side-by-side comparison. The reason we like these is because of questions like this last one we have up here. Is there an association between food preference and gender? So what we're wanting to know is when I look at my food preferences and I break them down by gender, does imposing gender on this show some type of change in the preference? So if we looked at things, we saw that percentage-wise, the preferences were about 35 for pizza, 45 for pancakes, and 20 for pasta. And we'll talk a little more about this later. And so association says, well, when we look at them in the smaller groups, is it different? So do the males prefer pizza just like the total group prefers pizza? Do the females prefer pizza like the total group prefers pizza? That's what we're talking about with association. So association just really wants to know, is there a difference from the between the marginal and conditional distributions? Is there a difference between the marginal and conditional distributions? So do these percentages look different than those percentages? Another way we can see that, look at your side-by-side bars. If it was really no different between male and female preference pizzas, or pizza preference, the males and females would both like it at 35%. The bars would look the same. The males and females would both look like pancakes at 45%. That's 45 out of 100. The bars would be the same. So if we're looking at a side-by-side graph, the graph shows us side-by-side. If the bars are the same, yeah, the bars in the subgroups look like the bars for the total group, the total sample. But if the bars are different, that means it was here at 45% when I looked at just students, but when I separated them to male and female, something changed. So that indicates there is some type of association there. All right, so I want you guys to look at what we've got right here. I want to see if you can write a statement for me on, is there some type of association between food preference and gender? Anytime we look for association, we're always going to cite evidence from the graph or from the table. So I want you to use the graph. I want you to describe to me, is there a relationship? What is that relationship? And what's the evidence of that relationship? So pause here for about 10 seconds and we'll see what you guys come up with. All right, so hopefully you were able to answer our question here, is there an association, using that graph? All right, and this is the type of answer that you should have come up with. This is going to be a little bit longer than the type of answers you usually give in math classes. Remember, statistics is more science a lot of times than it is math. We're trying to communicate between observations we've made, that's the science part, and the math behind them, that's the calculations that we do. So we've got to kind of tie all that stuff together, so you're going to have big, long answers when we're dealing with statistics. It's usually not short, quick things, it's an explanation. All right, so remember I told you there are 3 things. Is there an association? What is the association, and what's the evidence of that? So yes, there is an association between gender and favorite pea food, so we're stating the association. And now we're going to describe it. What is our evidence? Males are more likely to prefer pizza and pasta. We see that. Males had almost a 17% preference there, a 12% preference there on pasta. So males preferred pasta more, and females are almost twice as likely to prefer pancakes. So when we're describing this, we're describing almost as what's going on with pizza, what's going on with pancakes, what's going on with pasta. All right, so that's what we're talking about when we say describe that relationship or describe that association. So really just treating it as 3 separate graphs, and we're putting it all in one statement. Other things to make sure you look for is you describe all of them, because you could have some that don't have any association. Like we could have had the exact same effect for pasta. So a relationship with pasta. So both of them could prefer pasta at the same rate. So no association there, but in the other things there could. So that's why you really want to take it. Let's just take it one graph at a time. But where there are things that are in common, we can group them together just to clean up our statements and not make them as wordy. All right, so this is how you kind of our first little taste of analyzing categorical data, working with categorical data. Make sure we know how to graph it. So bar charts, identify when pie charts are appropriate. Make sure we can recognize what type of graphs we should use. As far as, do we use pictographs? When are they appropriate? So using non-scaled images. Make sure we're checking x-axis. And then the big part for us right now is being able to work with conditional distributions. So looking at the breakdown between two categorical variables and looking for an association. Do these percentages match up with the interior percentages? If it's the same for the subgroups and the total group, there's no association, meaning the second variable played no change on the first variable. But if we do see a difference between the marginal distributions, what's going on with the total group, and what's going on in the subgroups, then yeah, there's something that happens whenever we introduce that second variable. So that's the big ideas that we want to get from this. So thank you, and I will see you in class tomorrow, guys.